This is the solution video for section 6.2, problem number 22. All right, so we have the integral of the secant squared of 3x times the tangent of 3x dx. All right, so this is actually a very interesting problem because there's actually two ways that we can do it. All right, so I'm going to bring one over here. All right, now if I do it one way, all right, we're going to look at this. I have secant squared of 3x times tangent of x. All right, so what we're going to do, first of all, is we're going to think about u substitutions. Now, in this one, it only looks like the secant is a function inside of a function. Well, yeah, that is kind of true, but what we want to do is we want to think about our u substitution, right? So we could actually make two different u substitutions. All right, so the first u that we could make is tangent of 3x. Now, why is the tangent of 3x a good choice for a u? Well, because if you think about it, what's the derivative of u? Well, derivative of tangent is secant squared of 3x, right, times 3, right? So I have the secant squared of 3x. So if I chose that u, I would have u for the tangent 3x times the secant squared of 3x dx, right? Which means I would need a 3 with the secant squared, which means I need a 1/3 on the outside. All right, so that's one approach that you could do. All right, so then I would have 1/3 integral of u du. All right, and so I have 1/3 u squared over 2 plus c, or 1/6 u, which is tangent of 3x, quantity squared, plus c, right? So that's great, but you want to look at the other way that we could do it. Now, this one's a little bit trickier because we have to think about the integral not as secant squared, but now as secant of 3x times secant of 3x times tangent of 3x dx. All right, so now if I do that, I let u equal secant of 3x. Now, I'm only going to take the first secant of 3x to equal my u. So u, then I have secant of 3x tangent of 3x dx. So now that means that du would be, well, what's the derivative of secant 3x? It's secant 3x tangent 3x times 3, right? And then I multiply by the dx. So that means that I need only a 3 with the secant 3x tangent 3x. And that means I need a 1/3 on the outside. So it looks kind of like the other one, 1/3 integral of u du, right? That whole thing, 3 secant 3x tangent 3x dx is du. All right, but now it looks almost the same, except for the fact that when I integrate, I get u squared over 2 plus c. But what is u in this problem? It's actually different. It's secant of 3x quantity squared plus c. So now comes into question, are these two things equal? All right. So the fact is that they are equal because secant squared of x is equal to tangent squared x plus 1. So if I were to substitute out the secant of 3x, the secant squared of 3x, and put a tangent squared plus 1, and I distribute, so let's say I have 1/6 times the tangent squared x plus 1 plus c. The fact is that when you distribute the 1/6, you get 1/6 tangent squared of x, which is just like that. All right, but then I have plus 1/6 plus c. 1/6 plus c is equally arbitrary as just plus c. So these answers are equivalent.